Good evening. Today I'm Vamshi, and today we're going to discuss about assignment 4, convolutional neural network. In this assignment, we're going to learn about the convolutional neural network and how to build an convolutional neural network. So first of all, we are supposed to uh, import all the necessary functions, building functions, and libraries. So like NumPy, Matplotlib, TensorFlow, Keras. So in this assignment, we are going to build a convolution network using Keras, which is based on TensorFlow. So from the TensorFlow, we are importing Keras, and from the Keras, we are going to have all the of like convolution 2D, dense layer, flatten, and every built-in functions. So first of all, in this exercise, we are going to create. We are going to import data set called mnest, which has 10 different classes, and in the 10 different classes, this is mnest is nothing but the 1 0 to 9, 0 1 2 3 4 5 6 7 8 9. Those numbers are written, and those numbers have been have been written by human, and those have been used as a data set. And in this assignment, we are building a machine learning model, convolutional neural network, in order to identify the return number. That is, so if it is 128, sorry, if it is one, if is it 1, 2, or 3, that is written by an um, person. So, and also here the input is an image which is of which has image rows 28 and 28, dimensions 28 and 28, and we are going to import a shape. Input shape is so we have image dimensions as input shape, training, and testing. So here we have loaded the data set using explained y-train using mnest.load data, and then we are going to print the dimensions. As you can see, there are 60,000 in the extrain and 10,000 in the test, and the same the dimensions are showing 28 28. And then here the batch size is 128, necessary variable batch size, and number of classes, that is 0 to 9, that is 10, and epochs, number of iteration, that is 1. uh, Next, so we need to specify the image dimensions, that is so here we have and the input shape that is being printed 28 28 28 rows and 28 columns. And here we are going to visualize the dataset that we have loaded, mnest dataset that we have loaded, and using these lines of code, we can see the input labels, and we are going to, yeah, like normalize the input so that it is being used in the next stages. And we are going to visualize the sample images, that is this. And first normalize the inputs, that means pixel values from 0 to 1. That is, if you have RGB values, then that will be converted into 0 to 1. Here we are using Wi-Fi, we are converting by 255, because the size of the pixel is 255. The maximum size of the pixel is 255. So we are dividing it by 255 to normalize that. And then using those things, we are converting these classes into binary matrices. Like all the classes have been converted into binary matrices using keras.util to categorial, like converting the numerical values into categorical values. Then we are going to process the data, like processing the data set. We have finished the processing the data set. We got the data set, we normalized it, we have categorized the output, and now we need to build a convolutional neural network. Our first convolutional neural network, and the model is sequential model that we are using here. And in the question, the architecture is given as below. And the first layer has the 32 filters, and kernel size is 3 by 3. Activation function is relu, and the second layer is all of 64 filters, and size 3 by 3, and same activation function. Third layer, we are max pooling. Like first two layers, we are making a convolutional layer, and with 32 filters and 64 filters. And then next third layer we are max pooling from size, like we are pooling it max pooling from size 2 by 2. That means converting this 3 by 3 size to 2 by 2. And then next we are using a dropout with the ratio of 25%, that is 0.25. And the fourth layer we are flattening the data set and then flattening the layer, and then next we are converting into dense layer with 128 nodes. And next we are using a dropout function, a dropout dropout layer. The next, the final layer is we are using a activation function softmax, and then the output layer is then the output we getting is a required output. So here we are using a model sequential model and a model that add. So we are creating model as sequential model, and that we are creating each layer using the built-in function con 2D dense flattened dropout. So this two-dimensional uh, two-dimensional layers have been created using this built function with the given given inputs like filters, kernel size, activation, and input shape. Input shape is already mentioned above, that is 28, 28, and 1. So then next is we are giving the filters 64, 3 by 3 kernel, activation function value. As it is, the input shape would be same. And then next we are creating a max pooling dropout, flat and dense, dropout dense. Then next we are making a summary of the model that we have given. So here is the summary. So these are the parameters that have been used in this, and these are the total parameters, trainable parameter, non-trainable parameter. So the CNN is created. That means we have created all the CNN using Keras dataset. Now we are going to train the dataset using compile function, model.compile. We are given the loss function, the optimizer, the metrics. What is the metrics that it is using. So and we are using a dot fit in order to compile that. We are using dot compile, and in order to fit, that means in order to train the dataset, we are giving trained in dataset, and the batch size, validation data is, that is testing data. The next using, so we already trained the data and we have already validated. So next is we are going to find the accuracy. That is, we are going to find the accuracy using model that evaluate with the testing data set, and then we got the testing accuracy, that is 98%. And the data set would be, sorry, the model would be fitted. Now our next step is for the future purpose, we are supposed to save this model in the given directory. So we are going to model.save with the model, and then next we need to load the model that we have saved. That is load model. That is the, like, we are reloading the model into loaded model into keras.model.load model, and then model name is my model that we already saved it. And then next we need to apply the saved model again in order to evaluate it. So that we are just reconfiguring we are just re-evaluating our accuracy. So the stats accuracy, and we are rounding out with the 100%. That is, we'll be getting in the percentage. That is, we already got here 0.9842. Here also it is rounded out to two decimals, so that we got 98.42. And this is the accuracy. So we successfully created CNN. We have successfully saved it, and also we have tested the accuracy again. So we also got the same accuracy. So this is the segment 4 of convolution neural network, and this is, thank you.